So now I'm going to take you through different operators in Python. I'm just going to give you an overview of all the operators in Python. In total, we have 7 operators in Python. We have arithmetic, comparison, logical, bitwise, membership, identity, and assignment operators. So starting off with arithmetic operators. Arithmetic operators are operators that you use to perform basic mathematical calculations like addition, subtraction, division, and multiplication. So here are those operators: plus 10 minus 3 would be 7, 10 divided by 2 would be 5.0, and 10 divided by 10 multiplied by 2 would be 20. But there are 3 other operators. One is float division operator. So double backslash is a float division operator that you use to perform division again. But how this is gonna stand out from the previous division operator is this division operator is gonna return the quotient, but only the integer part of it. For example, if I divide 10 by 3. So when I divide 10 by 3, the quotient value would be 3 times 3 would be 9. And again, I have a reminder. So 3 again. Again, I got 1. So the quotient would be 3.3333, somewhere 5. But when you use float division operator, it would not return the entire quotient. It would just return the integer part of the quotient. That is nothing but 3. But when you perform the normal division, the slash operator for 10 divided by 3, it would return the entire quotient value. And we also have something called percentage operator, which is modular division operator here. And what modular division operator does is it is also going to perform division here, but it is going to return the remainder part of the division. So 10 divided by 3, the remainder would be 1 here. And finally, you have the final arithmetic operator that we have here is exponential operator, double asterisk sign, which means 10 double asterisk 3 in the sense it 10 to the power 3. So it's going to perform the exponential operation here. That would be 1000. The next operators we have is comparison operators. These are quite generic operators that you must have seen. The first, double equal to. In programming languages, if you use double equal to, it means equivalent operator. So I'm checking whether the one on the right hand side is equivalent to the one on the left hand side. If so, it is going to return true, or else it's going to return false. You have not equal to operator, less than or equal to, greater than or equal to. These are quite a generic operators. So these comparison operators are widely used in conditional statements to check for different conditions and perform actions accordingly. Next we have is logical operators. Logical operators are 3 here: and, or, not. And what do logical operators do is it's gonna let you check for multiple conditions at a time. And when you use and operator, each and every condition that you're gonna check has to be true in order to return true. So here I have 2 conditions. One is 10 equivalent to 10, and other one is 10 is less than 9. So when I say 10 equivalent to 10, it is true, so it's going to return true. And the other condition is not true, 10 is not less than 9, so that is going to return false. So altogether the output would be false because one of the conditions is false here. And the next one is, so let me run and show you, false. So if I put a greater than sign, then this would become true, which would in turn make the entire output as true because all conditions are true here. And we have or operator. Or operator is when you have multiple conditions, at least one of the conditions has to be true. So here, out of these 2, this condition is true, so it's gonna return true. Even though if all conditions are true, it is gonna return true. It's gonna return true, at least one of them is true, or else it's going to return false. And we have not operator. Not is nothing but just the reverse. So when I say 10 equivalent to 10, this is going to return true here. So that would in turn become not of true. So not of true would become false. It is just going to reverse the value. Next, we have is bitwise operators. So bitwise operators are nothing but where your interpreter would convert numbers or integers into bits and then perform actions on it. So like for example, you have multiple bitwise operators. Now taking this AND operator as an example. Now say it's 10 and 11. So it's going to perform an action on 10 and 11, but it is going to convert it into bits first of all. So for 10, it would be 1010, and for 11, it's going to be 1011. So now when I say 10 and 11, it's going to perform the action on the binary representation of these numbers. So here, when you use AND operator, you're gonna get 1 only if both the bits are 1. So considering 0 and 1 here, this is gonna be false, sorry, 0, because one of them is not one of them is 0 here, and here we have both bits as 1, so it's gonna be 1, and you have 0, so 0, and then both are 1 here, so it's gonna be 1. So now the output would be 1010, but it is not gonna return in the binary form. It's gonna return it in the decimal number. That would be 10 here. 1010 is 10. So there you go. And the next one we have here is OR operator. OR is quite the same. So we're going to perform OR operator on 10 and 1. So again, this is going to get converted into binary. So that would be 1010, and 11 would be 1011. So when you use OR operator, this line would represent OR operator. So when you use this OR operator, you at least one of the bits has to be 1 in order to return 1. So since we have 1 here, it's going to return 1. Here we have both of them as 1, so it's still 1. And both are 0 here, so it's going to be 0. To return 1 when you use OR operator, at least one of the bits has to be 1. So since it's 0, so it's going to return 0. And here we have both as 1, so it's going to return 1. So this would get converted into decimal again, that would be 11. So output would be 11 here. So there you go, 11. And the next is XOR operator. XOR is a little different from AND and OR, but just gonna follow the same. 10 and 11, say for example, we have 1010, and for 11 we have 1011. First of all, XOR is represented by using this sign, and here for XOR, your both bits has to be different. If it's different, then only it's gonna return 1. If they are same, it's gonna return 0. So here we have 1 and 1, which is same, and here also we have 0 and 0, so it's gonna return 0 here, and 1 and 1 would also be 0. So it has to have both the bits has to be completely different in order to return 1. So this the decimal number of this binary representation would be 1. So the output would be 1 here. So there you go. And the next one that we have is NOT operator. NOT operator is just gonna reverse that number. So if 0 is, so NOT of 0 would be 1 and NOT of 1 would be 0. Also, it's going to perform quite other, functions, which I have explained, in a separate video. I'm going to share that link in the chat, so you could, in the description, so you could just refer to that. Now I'll move to the next one, which is right shift. So here, just like the name suggests, it is just gonna shift the bits by the number it is represented. So say A right shift 1. So it's gonna shift each and every bit to the right by 1. So say I have 10 here. Okay. The binary representation of 10 would be 1010. So I'm gonna shift to the right. So this is right side, right? So I'm gonna shift this 1 to the right position, and then this 0 to this position, and this one to this position. So that would be 1, 0, 1. Since we have 4 digits, this position is empty now. Your empty positions will be filled with 0. Now this output would be, and then this would get converted into decimal. That would be 5 here. So if I run it, let's see the output. Nothing else. And we have left shift. Left shift is also the same, but it's going to shift to the left this time. So I have 10, which is 1, 0, 1, 0, but I'm going to shift it by 2 bits here. So that means, so let's say I have 2 positions here. So one is being shifted to the left by 2 bits. So I have 1 here, okay, to this position. Sorry, this position to this, and then 0 would go to, so 0 would go to this position, so that would be 0, and then this one would move to this position, that would be 1, and this 0 would be moving to this position, that would be 0. And the remaining position, so we have 2 more positions left, right? So till here we have filled it. So these 2 would be filled with 0, and that would be 4. And then we have 2. So you can also, it's like always we represent it as a 4-digit, 8-bit. I'm representing it as a 8-bit integer. So that would be 0, 0, 1, 0. 1, 0, 0, 1. So the binary, sorry, the decimal representation of this binary number would be 40. And how could you figure out what it is in the sense? By multiplying it with 2's power. So 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 4, and 5, 6, 7. So multiplying this with this and adding up the resulting value would end up give you the decimal number. So this, the first 3 would be 0, so let's not worry about it. So let's worry about the ones position. So that would be 2 to the power 3, which is 8, and 2 to the power 5, that would be 2 times 8 is 16, 16 times 8 is, sorry, 16 times 2 is 32. So 32 plus 8 would be 40. So this is how you convert a binary back to a decimal number. So there you go. You got 40 as the answer here. So these are the bitwise operators we have. And the next are membership operators and identity operators. And we also have assignment operators. So these are quite a simple operators. So talking about membership, we have in operator and not in operator. So in is nothing but this is gonna check if a particular item is present in an object or not, or a particular sequence is present in an object or not. So I'm gonna check. I have a list here, which contains 1, 2, 3, and 4. I'm gonna check if 1 is present in list 1. Print 1 in list 1, which means if 1 is present in this list called list 1, it's going to return true, or else it's going to return false. So since we have an item called 1 here, so it's going to return true. And not in is, next one is not in. Not in is nothing but this is going to return true only if it is not in that list, only if that sequence is not present in that object. So print 1 not in list 1. So 1, if it is not in the list 1, it's gonna return true. Since we have it in this list, it's gonna return false. We have identity operators. We have 2 of them, just like the membership operator. We have is operator and is not operator. So like how you used membership operator to check whether a particular sequence is present in an object or not, you could use identity operators to check 2 objects are same or not. So we have 2 objects, which is nothing but 2 variables here. Like we know everything in Python is an object. So A and B are 2 variables, which in turn can be also called as objects. So A contains 10 and B contains 20. So print A is 10, A is B, which means print true if A is same as that of B. So since it is not, it does not contain the same value here, so it's gonna return false. And I have A as 10 and B as 20. So print A is not B. So A is not is only if it is not same, it's gonna return true. So they are not same, so it's gonna return true. And finally, we have assignment operators. In general, a single equal to sign is what an assignment operator. So whatever you write on the right hand side of this assignment operator would get assigned to the one on the left hand side. So when I say B equals to 20, this 20 is getting assigned to B variable. But there are also certain other operators called addition assignment or subtraction assignment. Or you could also say multiplication assignment, and all the arithmetic operators we saw would can be used with assignment operators, which means excuse me. So when I say I'll go with B then. So B plus equal to 20. This is an addition assignment, which means I'm adding this 20 to the variable B and then assigning it back to B. So the variable value B would become 40 now because I'm adding 20 to the already existing value in the B and putting it back to the B variable or assigning it back to the B variable. So likewise, in the place of plus, you could use any other operators, any of the arithmetic operators. And these assignment operators would also work with bitwise operators. So we also saw a few bitwise operators, right? And or XOR NOT. You could also use those operators to perform the action and assigning it back to the same variable. And so here, I've also posted few other videos on division operators, division, modular division, and floor division operator. You could take a look at it in order to get a detailed understanding. I've also given few examples there, and also I've used a separate video on explaining this logical NOT operator in Python. I will add all the links in the description, so please take a look at it. We'll end this video here and we'll see you in the next concept in the next video.